Okay, so I'm going to introduce homeostasis and what that means in this short little video. So when we talk about homeostasis, it is basically how our body is going to maintain a constant, like internal conditions, like a steady state. So you can think about this little like board here, like in balance, right? So inside our body are different cells, organ systems are all going to work together to try and maintain a constant internal environment inside of us. So, for example, let's use blood sugar. So here, let's pretend that your blood sugar levels drop, you haven't eaten for a while, your body, actually, your endocrine system and your circulatory system are going to work to try and bring you back to balance. And then let's pretend you eat a meal, which is your digestive system. So your blood sugar levels rise. Again, it'll be your endocrine system and your circulatory system working to bring you back to balance. So when we think about like things inside of us that we try to keep balanced, blood sugar is one of them. So we try to maintain a constant blood sugar as well as a constant temperature. So as humans, we are 37 degrees Celsius or 98.6 degrees Fahrenheit. So when it's really hot outside, our body sweats, we get a little tired, a little lazy. That's our body's way to try and cool down and lower our internal temperatures to try and keep us at 98.6 degrees. But if it's cold outside, let's say it's raining or windy or snowing, and you don't have a jacket, now you have cold bombarding your body and you're trying to stay at 98.6 degrees on the inside, then your muscles are going to shiver to try and generate friction like this that creates heat to warm you up, right? Your blood vessels will actually constrict and move away from the surface of your skin. So you have your nervous system sending signals about the outside temperature to your brain. So you have your nervous system, your muscular system, your circulatory system, all working together to try and maintain that 98.6 degrees, keeping you in balance. Now we also, our kidneys actually, work really hard, and our hormones will work with our kidneys to try and maintain a constant water balance. Our cells are surrounded in water, right? And the inside. So they try to maintain isotonic conditions where there's equal amounts of water on the inside and equal amounts of water on the outside. So that's actually your kidney's job, your excretory system. But in reality, it's also under hormonal control, like hormones will actually talk to your kidneys and help them regulate your water balance. And then we have blood pH, which comes down to basically how much carbon dioxide we're producing and exhaling. When carbon dioxide stays within us, it actually reacts with water to form an acid. So your breathing can actually also increase when you exercise, trying to exhale that carbon dioxide to try and maintain constant blood pH. So let's try and just look at what happens when we exercise and how our body systems are going to work together to try and keep things in balance, or at least bring us back to balance. Here you're exercising, you're running down the block or the sidewalk or the track or something. We want to think about, well, what organ systems were being used here, right? So you have your muscular system. Obviously, your muscles are helping you to run, but those muscles need sugar. They need ATP. They need energy. So you're going to rely on your digestive system, and you're going to take in that sugar, hopefully ahead of time. But then it's going to be if you think about what's happening while you're running, you're breathing more, like your breathing increases, but your heart rate also increases. So here you have your circulatory system and your breathing. So let's think about our heart first. So our circulatory system, your heart rate increases while you exercise. And that's to pump the blood throughout your body to take that glucose and then the oxygen that your lungs are breathing in and carry the oxygen and the glucose to your cells. But at the same time, your cells, as they're making ATP in your muscle cells, are producing carbon dioxide as a waste. So then your blood is going to carry that carbon dioxide back to your lungs so you can exhale it. Otherwise, if you didn't, your blood pH would drop and become too acidic. So here we have a couple different organ systems all delivering different nutrients that are required and getting rid of waste, but all working together. Now, once you're done exercising, well, first off, while you exercise, you also get hot. If you ever have like run down the track before or something, when you actually produce energy in your cells, it also releases heat as a waste, kind of. And so heat is released, or a byproduct, not really a waste. And so eventually, after exercise, you also have to cool off. So you have to thermoregulate. So after exercise, your body has to return back to its steady state. So any sugar you used while you were running, you're going to have to replace and bring your blood sugar back to balance. Your carbon dioxide levels, as you produce more carbon dioxide and your blood became acidic, you're going to have to exhale that. But eventually you return to normal and your breathing becomes regular again. In your sweating and you're hot, eventually you sweat enough where your body temperature starts to cool back down and you're back to 98.6 degrees. So when we talk about homeostasis, really the big picture is, how do our cells, what are they doing at the individual level to help contribute to bringing us back to balance? But then those cells are part of tissues, and those tissues are part of organs, and the organs are part of organ systems, and they're all working together to maintain constant, like happy, stable internal environments inside of us. So that is my general overview of homeostasis. Each of my videos in this series will look at different examples of how our organ systems work together to maintain balance. Good job.